All right, I am back. I am still in the car waiting for this repairman. In the meantime, let's talk about a more contemporary account of regularity accounts of laws of nature, right? So Hume is several hundred years ago. This is the initial inspiration for this type of account of laws of nature. Um, but more recent philosophers have sort of honed it a bit and made it more explicit and more developed. So the author I've chosen is Swartz, right? And Swartz talks about regularity accounts. So Um, like Hume, he thinks, and I think this is still the case, right? Before you took a philosophy course, right, when you thought about laws of nature, if you ever thought about them, um, you thought of them as something like as governing, right, things or making things happen, right? And he wants to say, if you think about it, that is a very mysterious and weird thing to think exists, right? Laws that, again, like sort of somehow push the planets around or make it the case that I can't jump to the moon, right? Um, and like Hume, he's just going to argue that laws of nature are just descriptions of regularities we observe in the world. They just describe the world, right? They don't govern the world. Um, Certainly his account is inspired by Hume, right? We saw that Hume was assuming an empiricism, right? For his argument. So if you might not even buy into the Hume argument if you weren't starting as an empiricist, right? Swartz is not going to require that you be an empiricist in order to buy into his account, right? So uh, instead, right? But he's going to come to the same conclusion as Hume that we simply observe the certain types of things, follow other types of things. That's all laws of nature are. That's perfectly fine. We don't need them to be more robust than that. So Swartz sort of uses a little more subtle terminology. Um, he's talking about two different types of laws, right? So he talks about physical laws and scientific laws, right? So physical laws are what we actually care about, laws of nature. So these are the things that would be true whether or not humans ever existed, ever came to know them, right? Billions of years ago, before the first human existed, there were physical laws or laws of nature, right? Um, Scientific laws, those are the laws we develop in science and publish in journals and things like that, right? They're a product of human inquiry. Um, they're constantly revised, right? So our scientific laws are sort of trying to capture the physical laws, and we get it wrong, and then we revise them, and so on, right? Um, so if you were interested in scientific laws, then that's sort of a different thing. That's more the realm of sociology, right? You'd study scientists and see what they do. Um, what we're worried about and what we're calling laws of nature are physical laws, and those exist independently of whether science ever existed or humans ever existed, right? Um, and also, by using the term physical law, you might think he just means physics, but he's saying any kind of right law. Like so, laws there could be laws in psychology, economics, doesn't matter. Right? He's just saying whatever the laws of nature are. Okay, so what is a physical law? So Swartz sort of offers some kind of very minimal necessary conditions on what a physical law could be, and then sort of argues that that's all you need, right? So again, it's like Hume. He's sort of skeptic wants to cut down on all the extra metaphysical mumbo jumbo and just strip it down to the basics that we need, right? So a physical law is going to be true, right, all the time, forever. Two, it's going to be some uh, universal or statistical generalization, right? So it's what that means is it can't be a law that Nate's shirt is black, right? It has to be something more general. It has to have a quantifier in front of it in logical language where it says for all so and so's, right? Um, for all objects, if its mass, right, is x, then it will fall towards the Earth at such and such, right, acceleration. Well, I guess it's always the same, but you'll be attracted to another object of mass y, right, at by a certain way, by the what is it, squares, inverse of the squares of their or something like that, right? But you get the idea, right? It's supposed to be a general. It can apply to a wide range of objects. It doesn't pick out specific objects. That's the point of number two. Number three, it's going to be purely descriptive, right? And what that means is it's not going to name any specific items in the universe. There's not going to be laws that pick Nate out by name, right? It's going to be just these generalizations that pick out general classes of objects. And number 4, it's going to be a conditional. So that's, again, a logical thing. It's an if-then sort of thing. And it says, like, look, if X has, right, if this object has a mass of X and it is this distance from this other object with a mass of Y, then it will be attracted to the object with a force of whatever, right? So it's an if this, then that. They're going to be conditionals. And they're going to be contingent, which means they're not necessary truths. They're not mathematical truths. So they're not going to be truths of the kind like, right, a circle, all points on a circle are equidistant from the center. That's just true by definition. The definition of a circle, that's necessarily true in whatever universe. The laws of nature hold in this universe, right? But we can conceive of like a different universe where the gravitational constant is different and you would have a different looking place. So those are the 5, right? It's kind of a lot of conditions, right? So they're true generalizations, conditional in nature, don't pick out any particular objects by name, and aren't logical truths, right? He says that's all you need. That's a law of nature, right? You don't have to add like number 6, and they make the things do the things, right, that they do. They're just true generalizations. So now let's get into why he thinks that this minimal conception, right, of regularity, laws of nature as regularities is enough, right? And why we don't need the extra idea that the laws are somehow governing or doing more than just describing. So first he talks about how we understand truth, right? So laws are supposed to be true generalizations, right? So what is it to be true, right? Well, typically we think of truth as a relation between sentences and facts, right? So when I say my shirt is black, that's true just in case there's a thing in the world, right? The shirt belongs to me and it's black, right? And if this shirt was red, then it would be false, right? So a truth, right, is just I utter a sentence, right, proposition, and if it matches the world, it's true. If it doesn't match the world, it's false, right? So for example, the charge on each electron is negative 1.6 times 10 to the negative 19 coulombs. That's going to be true if and only if that actually is the charge of an electron, right? That is fairly straightforward, and that is how we think about sentences and truth in general. But if you think that laws govern, right, if you have this sort of thicker concept of laws, then what you end up doing is actually switching that relation and tipping it on its head and making your concept of truth very strange, right? So you would have to say, in that case, if you thought laws govern, that the reason an electron has the charge it does is because there's a law to the effect that electrons have a charge of negative 1.6 times 10 to the negative 19 coulombs, right? Somewhere there's a typo, right? But we get the idea. So that feels strange, right? It's much more straightforward, and it matches with the way we use like truth in everyday language. Is that like there's a way the world is, and then our laws, right, describe it, right? But to say no, these laws are like these kind of sentence-like things, these propositions that make the world the way it is sort of like kind of mysterious and sort of hard to wrap your head around what that could even mean. Right? So yeah, a governing law would have to be a special kind of proposition that doesn't take its truth from the way the world is, but instead makes the world the way it is, right? It forces nature to behave in certain ways. So could that be true? Are there really like 2 sorts of propositions out there, ones that describe the world and ones that govern the world, right? If so, the governing type would be these necessary propositions, right? This is the sort of necessary connections that Hume was talking about. And so call someone who believes in like this idea of laws governing, call them a necessitarian. And that's the terminology we're going to use moving forward, right? You've got regularity theory, which is Hume and Swartz, and you've got necessitarian theory, which we'll see we'll associate with Dretske, right? So notice that these propositions, right, would be true, right? These necessary propositions would be true even if the world were very different, right? So suppose there never were any bears. Well, if there were laws governing bears, the behavior of bears, those would still be true, right? They're just totally autonomous, right? They don't derive their truth from the way the world is, right? They're just out there floating. So before there were ever humans, there were laws governing human psychology, right? Um, and if humans had never evolved, right, by some accident, still those laws would be true, right? Um, maybe, right? There's nothing sort of logically inconsistent about it. He's just saying it's a little metaphysically weird to think that there's all these true propositions out there that describe things that, or sorry, that govern things that will never exist. So regularity theory says, why do we need all that, right? It's super mysterious what it even means for laws to govern. It really messes with our theory of truth, right? It makes now there's like kind of two different theories of truth for two different types of propositions, and these special propositions have this weird property that they are true no matter what the world is actually like, right? Um, he says, why do you need that theory? You don't. Like, let's go with simpler regularity theory. It just denies that any sorts of those types of laws exist. There's no autonomous subjunctive physical laws. And again, subjunctive just means like counterfactual, like it describes things that don't actually exist. It says all we need is physical laws that just describe the world, period, right? Um, if we go for the regularity theory, then we only need a single theory of truth, right? And the laws, when we say the laws of physical laws are true, we mean true in the exact same way of all the other sentences, right? They just describe the world accurately. So it seems attractive, right, to give up on this sort of intuitive necessitarian account of laws. Um, he says all you really need to do is perform a Gestalt switch. But by that we mean, I don't know if you've ever seen this duck rabbit here, right? But like you can look, and on the left you can see those two little sticks as the duck's bill, right? And then the duck's eye there. Or you can see those two little sticks as the rabbit's ears, right? So, and you kind of like, you can see it as a rabbit, and then you sort of switch to seeing it as a duck, and we call that a Gestalt switch, where like the overall sort of look changes, right? He's saying, do that with your account of laws of nature, right? Just give up the necessitarian view and do a little Gestalt switch in where you see that laws of nature just describe a world that is already orderly, right? Um, the laws don't make the world orderly, right? It's not a necessary truth that the world is orderly. Um, it just happens to be that way, and we can describe it, right? Um, now, if you find that unsatisfying, you say, no, I want to understand why the world is orderly. It says, yeah, I understand that feeling, right? But like necessitarian laws don't really help, right? They don't make it make more sense, right? So does it help you if you want to know why do electrons have that charge, right? And if you say, oh, well, there's a law that says they have to have it. Did that explain anything really? Not really, right? It doesn't give you any more than the pure descriptive theory, and the descriptive theory is just so much more sort of like metaphysically austere. And there's a general tendency in philosophy to say, hey, if we can sort of explain everything without having to posit all this extra weird stuff that we're not sure exists and have never seen, right, and don't even totally understand, let's not, right? Let's keep it sort of simple, right? And this is what Hume is saying, and this is what Swartz is saying. So to more explicitly, right, what we've sort of been talking about what we call a cost-benefit analysis, right? So what do we get out of this theory for all the extra machinery that we're trying to add, right? And why not just stick with a simpler one that gives us more bang for our buck, sort of, so to speak, metaphysically? And so he runs sort of a cost-benefit analysis, right? So necessitarian laws don't really have any what we call theoretical virtues. By theoretical virtues, we mean like we like theories. We think the best theory is like really simple and explains a lot, right? And so if I'm gonna, this was what Churchill was talking about with Occam's razor, very similar thing, right? If I hear a bump in the night, which theory is better? The theory that it was my cat, since I already believe in cats, or that it was a ghost? The ghost adds a bunch of stuff, like I don't need to explain it, right? It's sort of a bloated theory. We like lean theories that can explain as much as possible, right? So he says necessitarian laws aren't like simplifying anything. They're just making it more complicated. They're not explaining any more, right, than the mere regularity theory. Um, and Hume has shown that we don't experience them, so there's no reason to believe in them sort of empirically. So why even bother with them, right? And not only that, but the regularity accounts, the simpler accounts of physical laws, the descriptive accounts, have certain advantages. So first of all, um, by getting rid of all this extra sort of metaphysical baggage, right, about governing laws and the mystery associated with what that could even mean for laws to, again, make things happen, um, it sort of like places regularity theory in agreement with this sort of general empiricist tradition that pervades science and has really been quite successful, right? You can't deny that science has been doing pretty well lately. And science is basically an empiricist enterprise, right? So, for example, in the past in science, there's been sort of like concepts that we thought we needed, but we've ended up just sort of like being able to just cut out of our theory, like vital force. We thought for a while we need to explain life by some extra special force, right? That gets so the difference between a living being and a rock is that the living being has a vital force. Um, we don't need that anymore, right? We're able to explain life without that concept, right? So similarly, if we can explain everything, right? If our regularity laws can do the job, right, then we don't need the governing laws. They're sort of unnecessary and metaphysically sort of suspect. Another benefit of the regularity theory is it places the special sciences like psychology, economics, things like that on the same footing as laws in physics and chemistry, right? Um, so if you're a necessitarian, you think about governing laws, typically they're going to say that like you've got these fundamental, really basic laws, the laws of physics, and then everything else, right? The laws of chemistry, biology, right? Psychology, economics, those are somehow derived from the more basic laws by interactions of the more basic laws. Um, that's an attractive prospect, right? To be able to, we call that reduction, be able to reduce everything down to physics, right? And down to these very simple basic laws. Um, the problem is that it's probably impossible, right? Um, Gary Fodor has an influential essay where he argues that it's impossible, right, to reduce everything, particularly stuff like psychology, down to physics, right? Um, so regularity theory says, look, that's no problem, right? We don't have to worry about reduction. Any regularity we observe is a law, right? So it could be a psychological regularity, it could be economic regularity, right? If we view it constantly, right, if it happens over and over again the same way, then it's a law. We don't have to worry about then also reducing it to physics, right? Um, Also, a benefit is if you, I don't know if you know anything about quantum mechanics, right? But um, the success of quantum mechanics as a description of fundamental particles has introduced statistical laws, right, into sort of the basic laws of the universe. So it's hard to think anymore that the laws of the universe are deterministic, right? It's hard to believe now that if you started the Big Bang and you knew all the laws of physics, you could predict everything that would happen forever, right? It turns out that as Einstein had a problem with this, but he said, you want to say God doesn't play dice with the universe? Turns out probably he does, right? Probably some stuff happens and you can't predict 100%. You can only predict sort of what the probabilities are of what happens. And regularity for a regularity theorist, a statistical law is just as good as a deterministic law. It's just a regularity, right? So it seems to be some benefits, right? Regularity theory seems to sort of accord with where science is going. And finally, an extra little bonus, he thinks that regularity theory solves the problem of free will, right? Um, so we haven't talked about the problem of free will in the sort of metaphysics section, but the basic idea is like, if the universe is deterministic, right, and science in principle could predict everything, then do we ever make a choice, right? Or are all of our choices just determined already by our neurons and our brain chemistry and everything that sort of from the Big Bang on, right? And even if it's not deterministic and it's probabilistic, that still doesn't give us free will, right? So just because it's a matter of chance whether what I do, right, and it's still not up to my choice, right? So it seems like that's like a 30-second condensation of right the whole literature, the problem of free will, right? But the point is, on a scientific worldview, it seems hard to see where you could fit in um, humans sort of being the originating causes of their actions, right? It seems like, well, everything is in a causal chain all the way back to the Big Bang, right? Um, and Schwartz thinks, well, yeah, it doesn't. Again, we don't have to worry about this view of the universe. Regularity theory just says it just describes what happens. So if I make a choice, right, and something happens, then that's free will, right? That gets us free will according to regularity theory. That's often a little tangent. I think you could probably push back on him on that. He's sort of piling on. Uh, he doesn't need number 3 to make his point, right? Maybe it's an interesting point. Maybe you want to argue with it. And if we don't cover free will, if it's something that you've thought about and are interested in, you could try to push back on Schwartz on this point, right? Because I think it might be a little underdeveloped, the idea, the point he's trying to make here. But to make his more general point, he doesn't need it, right? And the more general point is like Hume said, right? Hume's point was laws of nature conceived as necessitating events. That concept is empty because it doesn't correspond to anything we observe. Schwartz is making a different sort of argument. He's saying we can have a perfectly good account of laws of nature without them being governing laws. They can just be regularities, and that's just fine. In fact, it's better. It has all these benefits, right? Without the metaphysical mysteriousness of laws somehow, again, making things happen in the world. So I hope that makes sense. I think, the philosophy of science thing, it's of interest to me. It makes philosophy engage, I think, with like current important things. And so I like to cover philosophy of science, right? In case some people think, oh, philosophy is just arguing about like whether tables exist or whether tables are just collections of particles or something, right? And some of philosophy is like that, like the ship of Theseus. You might say, who cares, man? Who cares if it's the same ship? Well, maybe you think, science is pretty important and we should get a better sense of what we're talking about when we talk about laws of nature. And so that's why I talk about it, even if, some people are going to love it. Some people, it might be a little difficult. But if any of it is difficult, come talk to me, come talk to Andy, send us emails, come to office hours. We're happy to work through it with you. So next, we will start seeing some problems with these regularity theories posited by Hume and Schwartz.